All right, without further ado, we will get started. Thank you again in advance for attending the Vendia Share Developer Preview webinar. I want to quickly cover what we're going to go through today. We're going to start with some logistics about the webinar, kick off with some introductions to the panelists speaking with us today, look at some background around some of the problems in terms of data sharing and code sharing that have led to the creation of Vendia, talk about how it works, look at a nice demo, and then dive a little bit deeper into the internal mechanics. We're going to finish up with some advanced topics, things like integrations and how to get started on the next part of the Vendia architecture adventure. And we'll talk about how customers are currently using Vendia and what they're building on top of the platform. We've got the question and answer feature turned on today, so please feel free to post questions as they may come up. Brian McNamara has graciously volunteered to try to answer those as they come up. And if we don't get to anything in terms of your questions, we will reserve some time at the end of the webinar just so we can cover those. We might cherry pick a few and kind of talk to them at more length. So definitely feel free to use that as well as the chat features turned on for the webinar today. All participants are muted today, and we are recording. The session will be made available here within the next day or two, and you'll get a link for that, as well as a follow-up survey, just so that we can make improvements as we progress in our webinar series. All right, so without further ado, let's kick off some introductions. My name is Cory Forsythe. I'm a solutions architect here at Vendia, based out of Dallas, Texas. Formerly, I was working with AWS as well as ServiceNow as a solutions architect, professional services consultant, and even a support engineer. My background is that of a software developer, as well as a Cisco networking instructor, and even an agile software manager. So I say those things hopefully just to let you know that I can kind of address questions as they come up from those points of views and talk a little bit more about that experience. With me, I'm joined by Tim Wagner. Tim, would you like to introduce yourself, please?
Good morning, afternoon, or evening, everyone. And thanks for the intro, Cory. Great to be here. Tim Wagner. I am the co-founder, along with Shruti Rao, as well as the CEO of Vendia. My most recent background includes two roles that actually are closely related to what we're going to be chatting about today. I've been the VP of Engineering at Coinbase, one of the probably few companies on the planet that gets to run distributed ledgers as one of its most core mission critical data structures and processes. So it gave me a front row seat, firsthand experience in seeing what it's like to operationally manage, and frankly, what some of the challenges are in existing distributed ledger technologies, especially when it comes to enterprise challenges like scale and throughput and latency. I also was instrumental in bringing serverless to AWS, wrote the original, as Amazon will call it, working backwards document for what eventually became AWS Lambda, and then went on to serve as the general manager for that unit, including API Gateway, Lambda, and a couple of the other services around there. And have a background in startups and other enterprise companies as well. So great to be here today. Really looking forward to chatting about some of the things that we're bringing to market for developers.
Awesome, Tim. Thanks so much. Also, we're joined today by Brian McNamara, one of our solutions architects here at Vendia. Brian, care to say a few words?
Absolutely. Thanks for the introduction, Cory. Hey, everyone. My name is Brian McNamara. I'm a solution architect here at Vendia. I live in the New York metropolitan area, about an hour west of the city. In a previous life, I was a solutions architect at AWS who really, I'd say, focused more on our serverless offerings like Lambda, API Gateway, et cetera. In previous roles, I worked in healthcare startups, fintech startups, and managed service providers, mainly doing, I'll say, cloud operations and administration work. So with that, I will turn it back over to Cory.
Awesome, Brian. Thanks so much. All right, let's kick it off with a little bit of background. And that's really what we're here to talk about today is, sharing data is hard. So we want to take a look at, well, why is it hard? The answer, data silos have really been a pervasive thing in any company. And we found that they're certainly worse at scale. When we say things like silos, what we're speaking to is data that's separated from the rest of the organization, or perhaps the rest of the team, or another team, or even with your partners and customers. This may be a result of organizational boundaries, perhaps technical limitations, or something similar. When data is siloed, classic governance problems arise. These problems might include difficulty classifying data, knowing, for example, what type of data we're working with. Is it IoT? Is it some kind of application data, customer data, et cetera? With that also comes challenges in terms of visibility into compliance needs. What if that data is subject to particular compliance like HIPAA or PCI, for example? We have to be able to understand the classification of that data to address whether it does need to follow controls for compliance. It also leads to an inability to enable other workloads with existing data. And this reduces the value of that data or otherwise makes it difficult and less economical to store. After all, if we don't know what we have, do we know what we're paying for? This problem really is old as time. The example I love to speak of when we talk about data silos and the difficulty with sharing dates all the way back to like the Roman Empire, when it was difficult to orchestrate sending out information to all the different troops and movements and different, quote unquote, organizations within the empire. The problem is as old as that time and still persists today. The one thing that we've noticed is that from then to now especially, but in more recent times especially, the truth is the amount of data that organizations work with has expanded and will continue to expand. And with that, we found that tool chains to govern and transport that data have largely remained the same, especially when we're talking about doing so across those boundaries, clouds, accounts, and partners and customers, et cetera. And as organizations adopt cloud and IoT technologies, they begin creating as well as consuming massive amounts of data. Exploration into things like artificial intelligence and machine learning or other, quote, big data workloads expand this volume of data as well. With the additions of these technologies, we find that the number of cloud environments, hybrid solutions, and data stores and technologies, the list grows. All of this data might be found in systems like databases, data lakes, CRMs, or ERPs. The list continues to grow as we see new technology adopted in the specific industries. Each of these systems or these data stores might have its own governance approach. They might implement different mechanisms for transporting data, and they may differ in how they're accessed as a result. So Tim, let me ask you, if I may, what kind of data silos or other challenges with respect to sharing data have you seen in customers through their journey?
Thanks, Cory. As you say, it is a very old problem, certainly one that predates computers. But the really intriguing thing here is how recent technical innovations have created new opportunities in this space. Let's start though by talking about what some of those challenges are. I mean, they really span the gamut here. There are operational challenges. So anytime you want to just get bits from one place to another, when that means crossing clouds, accounts, regions, owners, tech stacks, that alone isn't necessarily easy. And then a lot of people kind of point to APIs. Certainly, I've been someone who sold APIs in the past. APIs are great, but to be useful, data also has to be consistent. It has to be complete, it has to be shared in real time, it has to be current, and it has to be deeply and easily integrated into existing systems and processes. If you're not achieving all of those things, and APIs really are just kind of one small piece of that much broader puzzle, it's difficult to take that data and really make it meaningfully integrated and shared across all of those different entities. You can imagine this, for example, just two companies, for instance, polling each other constantly, trying to get to a source of truth, where neither one necessarily has a complete picture or ever has a fully up-to-date picture, and what some of the challenges might be, and then extending that from two companies to a supply chain involving hundreds or even thousands of companies. You also mentioned governance, Cory, and access control is another essential piece here. It's not just enough to move bits from point A to point B to give access maybe to something like an S3 bucket. You need to be able to reverse that. You need to be able to know where has your data been, who's seen it, and potentially recall access to it in the future. That's always been important, but it's become even more important. Things like like GDPR and the recently passed CCPA in California. These types of regulations only make it even more critical to have the ability to govern your data, audit your data, know where that data has been and who's using it. And then finally, I say, customers have lots of different kinds of data to share. There's everything from fine-grained transaction data, like IoT, sensor, business data, but also bulk data, Parquet files, images, multimedia, and customers need a solution that embraces all of that, not just 10% of their data or data that only happens to be in a single particular format. And this problem, of course, is pervasive. Every industry has to track and trace. Every company has a supply chain of some form, whether it's virtual, physical, and pretty much every company out there has to keep track of customers, taxes, employees, contracts, orders. It's really something that spans every industry sector and segment.
Excellent, Tim. Appreciate the insight. Two takeaways from that I heard were, data one has to be useful, and then that utility has to apply not just to the 10%, but for the entire platform upon which we're presenting data. So I think those are some key takeaways. So how do we address some of the fundamental issues that make sharing data difficult? Well, one of the critical tools to solve this problem could be a data catalog. I'm always reminded when I say the word catalog of, like circa 1997, shopping for computer hardware in a catalog and actually like physically inspecting the pages and making a phone call long before the days of e-commerce. And data catalogs kind of offer us that same notion in terms of being able to advertise data and push out that catalog, those pages that describe what data is available in the organization, and then also to push out things like taxonomy and metadata. This allows for consumers of the data to potentially go find what they need. And data catalogs are really useful for a number of data workloads. Unfortunately, they do us a bit of a disservice in terms of highly ephemeral data, such as that we find in the IoT space, or also session state storage from web applications come to mind. Quite simply, this data changes too frequently and may represent highly fluctuating workloads. For example, let's consider a piece of state that's generated by a serverless applications with resources that have been scaled up and scaled down during some periods of peak processing. If we look at this from the left to the right on screen, a customer is simply making a request to a cloud function. A cloud service provider is picking up that request and managing some compute behind the request to fulfill it. And then as a result of that request being fulfilled, some user states being persisted to a data store, let's say a database. So do we catalog that data? And how would we classify it? Is it potentially just system data? Is it something more akin to shopping cart data? Does it have any value in the long term? And if so, who might need it? And how do we ensure that they're made aware that we have it? For a handful of transactions, this is pretty easy. We just stick it in a data catalog. But what if we have millions? And what if we only need the most recent copy of the data, not all the millions of past data? You can see how asking such questions can quickly distort the value of something like a simple data catalog. So at this point, we're asking ourselves, how can we effectively share data when its scope is rapidly changing? And how can we endure through data classification and advertisement when the amount of data becomes just too much for human eyes or human hands to produce into a data catalog? Add to that the technical complexity of actually physically sharing data from disparate systems. This is very difficult. Some reasons that come to mind are technology differences, access patterns, or differences in controls. Many industries and technically inclined organizations have sought to introduce an element of decentralization and self-service, or at least self-service with respect to data discovery, to address these concerns. After all, if data is made available via self-service platforms, the location of the data and the interface is really all you need to go get it. To solve this problem with advertisement of available data, blockchain technologies are often used. Blockchains offer a decentralized data catalog that is really easy to consume. This can help with that advertisement problem, but there are some drawbacks. And Tim, I know you've got a lot of experience with blockchain technology and organizations that use it as a mechanism to help unblock some of these issues. I understand, however, that the technology itself typically comes with some operational and some scaling burdens. Can you tell us a little bit about what you've seen in this space leading up to your work with Vendia?
For sure. I will say, like, some of these limitations and challenges were part of what led us to want to start this company and explore this space to give customers an easier and more straightforward way of dealing with their data. Let's start with what's great about blockchains, and maybe we'll think about this as kind of the distributed ledger piece. Having a data platform that can span clouds and owners it's a fantastic thing, right? It's a really good idea. It's also one of the ideas at the heart of Vendia. And one of the things that's actually challenging about serverless, for example, is that people often point at it and say, well, hey, it's proprietary, it's single cloud. So one of the nice things about a distributed ledger is it gets us to a solution, to a data model and a data layer, a data tier in an application that can span clouds. It can span technology stacks, span owners, span accounts, span regions. That's the really good part about it, right? And Vendia absolutely is excited about that piece and leverages that fact with our distributed ledger technology as well. But in current blockchain approaches, things like Hyperledger Fabric or Ethereum, for example, there are a lot of difficulties in turning those into enterprise solutions. With something like Ethereum, part of that is that the public blockchain wasn't necessarily designed with the enterprise in mind. So things like 14 transactions per second of throughput, latencies that can go up to 15 to 20 minutes, $1 or more per transaction in transactional costs. These are not particularly well suited to enterprise needs where you might have thousands or even tens of thousands of transactions that need to be processed per second, where you need those transactions to happen with sub-second final commit times, and where you need to be able to process them at fractions of a penny per transaction, not dollars or even multiple dollars per transaction. So getting to something that has the right kind of scalability, throughput, latency, and then the other side of that, of course, is enterprise integration. And here's a case where, even with something that is more enterprise focused like Hyperledger Fabric, it can easily take 12 to 18 months to get through a pilot between having to select the technologies, deploy them, scale them effectively to peak capacity and so forth. I mean, that takes a team, it takes time, it takes people and money. A SaaS delivery, however, is something that any company could put in place very quickly and very effectively. And so some of these challenges led us to think about, and with Vendia, how could we do all of that in a better way? How could we deliver that distributed ledger capability, but in a SaaS fashion? How could we use serverless to solve some of the problems of blockchain by basically putting a supercomputer inside every node so it can scale and be incredibly, incredibly powerful? And then also make sure that it scales down and turns off so that when you're not processing anything, you're not paying anything. And so some of these challenges that I got to see, especially sort of in my time kind of working with blockchains and some of the distributed ledger tech that's out there today, really informed how we thought about doing a better job of that with Vendia.
Excellent, Tim. Thank you. I appreciate the insight. Some of the things you mentioned about blockchain technology I find interesting. There's certainly that real advantage in decentralizing our data or our data catalogs. But of course, it comes with some of the challenges that you mentioned. It doesn't scale particularly well, at least not in the form that most of us have seen. And to add to that, I think organizations have found that they have a hard time with the leap in adoption required to really take on things like data modeling. And actually using the blockchain can be a tremendous undertaking for some organizations. We've seen this problem in the industry before, though, specifically with compute. I think that that you mentioned serverless there is a perfect segue. We find when we talk about these technologies that we ask these two questions here. Wouldn't it be just nice if it just worked? And what if it could behave like serverless? So we'll uncover those a little bit as we go through the remaining slides. So let's spend a few moments first talking about how Vendia helps us with our sharing problems, and then we'll take a look at it for ourselves. To answer how it helps, we must, of course, understand what it is. So let's talk about some of the highlights. Vendia Share is a service, and just like any service, your departments, companies, and partners can subscribe to that service. Today, we're in developer preview, so I definitely encourage you to go check out the service itself and sign up. The Vendia Share service is, quite simply put, created to make sharing of data and code easy. This is regardless of where you are, who you're sharing with, or what technology is being used. And as we've kind of started to unfold, data in Vendia Share is backed by that distributed ledger. It's been said that Vendia uses the best of that blockchain technology, really without all the burdens that come with it. Ultimately, what this means is that your data is consistent, it's correctly ordered, and it's made available in real time to all parties. And furthermore, data lineage is preserved through the ledger such that we can view the state of data now and how it's changed over time. There are many ways to get this data in and out of Vendia Share. Principally, customers will use a GraphQL API. We'll see that momentarily. One of the great features of Share is that you are provided with a zero-code API using this technology. You don't need to have resources like software developers to build the API or even to design its components. You simply tell us what your data looks like in terms of a JSON schema that we'll take a look at, and we build everything for you automatically. And I mentioned APIs there. In my time at AWS, I often quoted the great sentiment there that APIs are the glue that connects microservices. In my time there, I often found, though, that APIs can be a bit of a sticky point in terms of architecture. There's a lot of different options in terms of the technology to build them. And many people seek out expert advice in terms of how to correctly build and operate APIs at the necessary scale. So the fact that we are able to provide one based on the data model with zero code is a huge advantage. Before we dive under the covers with Vendia Share to see how it works, let's take a quick moment just to get to know each other a little bit better. I'm going to go ahead and place a poll on the screen. You should see that momentarily. Take a quick moment to review the questions on here, and then we'll talk about the results here after we go through a demonstration. All right, so with the survey closed, let me go ahead and change gears. I am actually going to jump into a live demo via screen share. So I will stop sharing PowerPoint momentarily, and we're going to jump into a web browser instead. That may take just a moment to transition for everyone, but I've taken us to a new browser window, and I've logged into the Vendia Share service. Again, this will be a service that you have to sign up for, but once you've got your credentials, this will be really similar to the view that you see. We're brought initially to our uni dashboard. So before I dive into all the functionality here, I want to quickly cover that term uni. So uni, or universal application, is what the service provides you in terms of a platform upon which to share data, upon which to build applications, to add partners, etc. So it is really core to the service. And to demonstrate what goes into that, we're going to take a look at creating a new uni and the inputs to do so. And then we'll take a look at, well, what's actually built and how do we interact with data within a universal application. So let's go ahead. I'm going to click the Create a New Uni button and start diving in. We're just going to quickly call this Uni Test Webinar, and I'm going to give it some numbers just in case I had one named that already. We're initially given some sample data that we can work with in terms of what is going to be presented here on screen. Let's just quickly walk through these items. On the left here, we're going to start with node config. So this is our node configuration in our uni. Unis are comprised of nodes, and we'll take this apart, this concept of nodes, as we dive in a little bit deeper. But effectively, a node can represent something like another team or another region in a multi-region application, perhaps another cloud account, perhaps even another company in terms of working with partners. So for the sake of argument, let's just pretend that we have two different nodes, and we're going to deploy them to two different AWS regions, in this case, East and West. And I'm just going to give these some names: Webinar 1 and Webinar 2. Looking to the right at the Uni Schema panel, as I said earlier, the principal way that you'll work with data in Vendia Share is via an API powered by GraphQL. Well, this API is actually generated from a standard JSON schema. We'll probably have some deep dive sessions in terms of webinars later on, but I encourage you to just check out our documentation in terms of where that JSON schema came to be, why we use it, how we use it, etc. Important takeaway today is that it is representing the model for our data. In this case, we're presented with a list of shapes. Let's go ahead and just take a different example so I can introduce you to our quick starts. This is a great way to get started on your own with the Vendia Share service and creating universal applications. We've got a growing list of quick starts that speak to some very generic use cases as well as some very specific industry use cases. I've pulled up our shopping list example here, which I like to use. So I'm just going to quickly show you how quick it is to simply come in here, copy, paste, done. So now we have a universal application that is going to help us store shopping list data and work with shopping list items. The one part we haven't covered is the initial state. Initial state gives us an opportunity to prime the universal application with some initial data, some initial state. So this can be useful if we've already got some data to bring in, or if we have some core domain knowledge that's pertinent to an application that we might be building on top of the service. I'm going to go ahead and grab our sample state, which has a couple of items on our shopping list, namely a loaf of bread and 2 pounds of cheese. And let's paste that in there and hit create. And we'll see the uni gets registered, and then we're brought to a view here where the nodes are deploying. Again, we created a universal application with 2 nodes, both representing different regions in terms of the AWS cloud provider to which they're currently being deployed. As it says, it's probably going to take about 5 minutes for that to deploy, so we can come back to that and look later. But if we come back out to the dashboard, I did stand up another shopping list example earlier today that we can take a look at. You'll see the status here indeed is running, and we're presented with a few things, a couple of cards that represent our different nodes, and the resources, or at least some of the resources provisioned with those nodes. I'm going to save the resources for a little bit later. We're going to cover that in more detail. For now, I'm going to open up our GraphQL Explorer. This is a really cool tool built into the service that allows you to explore the data. Again, GraphQL is the underlying API technology. So what happened is that in the background, when I was creating this uni, the data model I presented was dynamically used to generate this API for us. And this Explorer tool uses that very API. So we can immediately start to do things like perform queries or mutations, which is GraphQL speak for changing things or adding new data. In the same way that I just primed our new uni with initial state data, I did so for this example as well. So I should be able to come in here and configure a new query. I'm going to simply tell it what fields that I want it to show me. And immediately we can see some data. I think I added toothpaste at a later time there, but we see the loaf of bread as well as cheese. And we can just as easily start working with data. If we were to add a new mutation, for example, I could add a new shopping list item. And if I specify a couple of fields here, I can quickly start to tell the story about adding some new data. So if I want, for example, potatoes come to mind for some reason. I'm going to say that I haven't bought them yet, so bought is false. I just want one. And then nice feature of the Explorer here is I can go ahead and execute that query. In this case, it doesn't look like there was any error, so I should be able to go get that data. And we'll see eventually that potatoes is available there too. So let's go ahead and back up to the dashboard. And I'm going to come back again through that view. Let's see, the webinar was the one we just created. Oh, I think it's still deploying. So we'll continue down the existing example. What I want to do is show this works cross node. So I've copied our existing query from the first node, and I'm just going to run that query from the second node. And let's see what we got. Oh, there's potatoes. So why is this interesting? Well, if you recall, when we added this data, we were on the first node. I believe that was the US East region in AWS. And I've just queried it from the West region. So you can see some value there already in terms of the operational burden. I didn't have to copy the data. I didn't have to manipulate it in some way. And if I query this, regardless of where I'm at, it's going to be the same record. And we can use identifying fields here to verify that. So just a really quick demo. The one last thing I'm going to show before we move on today is, if I hop back in, is the invite button here. So very, very, very simple interface. But once you are registered with Vendia Share Service, we'll of course capture your email as well as the email addresses of partners, etc. And it's really easy to invite somebody to start sharing my shopping list. So if I were to invite Bob at Vendia.net, for example, say we had a Bob would receive an email, and it would have a link where he can click in, come to the share service, set a password, and immediately start onboarding a new node. This is really cool because as my access patterns change, maybe I need to add additional AWS regions to my multi-region application. Maybe I'll start interfacing with customers differently, or more commonly, maybe I'll start interfacing with a new partner. So Bob, in this case, might be running some analytics software for me. As a SaaS service, I can invite him. He gets his own node. Data sharing is easy. All right, and with that, let me quickly transition back into PowerPoint. Oh, and just a side note, the link for that shopping list quick start, should you want to walk through and use that same schema, will be on the slide deck. All right, so let's talk a little bit about what just happened, and then let's start to unfold all the different pieces and parts that went into making that work. So in just a few minutes, we stood up a brand new universal application, or uni. Behind the scenes, cloud resources were generated for us, and we'll take a look at those in more detail. More importantly, we saw that GraphQL API was generated from our data model. We consumed some initial data from our init state field where we added that bread and cheese, and then that was immediately distributed. We could query it on other nodes immediately. So let's unpack some of these items in just a little bit more detail. So we mentioned that the Vendia Share Service creates cloud resources for us. Oftentimes customers ask us, well, what resources are created? And then who can access those resources? Are they shared? And these are all great questions, and we take them very seriously at Vendia. Data privacy and things like noisy neighbor effects and other considerations of classic multi-tenant architecture can be quite difficult. So we do things a little bit differently here. And Tim, could you talk us through a little bit about what's on screen here in terms of the STAMTI model and why we use this to speak about Vendia Share?
Let's think about some of the requirements here to make this work well. One of the things that needs to happen in order for that demo that you just showed to work is that every one of these participants, every one of these nodes has to have its own copy of the data. They might be in different accounts. They might be different legal entities. They could be different companies, maybe different departments or wholly owned subsidiaries within the same company. They might have, they might be in different regions, even different cloud providers. And so they all need to have their own copy of the data. They also need to be able to set up their own independent operational controls. So more on that later. We'll come back to that in a second. Now, there are a few different ways people have kind of classically architected. If you think about a cloud service provider, Cory, if you and I each had went to say AWS or to Azure or to GCP, and we each kind of each grabbed a server or some other cloud resources, those would be in different accounts. And between those accounts would be this incredibly strong firewall. That firewall would be there for security reasons, for operational isolation reasons, and also to make sure that anything that you set and anything that I set are completely independent. Neither of us, unless we've done something special, can go influence the other one. Now, lots of great things about having that firewall in there. One thing that's maybe not so great about it, cost, because everything on your side of the line, everything on my side of the line, all of those things have to be duplicated, stood up independently. We can't really share those capabilities with one another. Now, another and sort of the other end of that continuum, if you think about maybe how a classic SaaS company might operate, they go grab a database, they put lots of customers into the same database, and so they get a really cost-effective way of multi-tenanting that information. And that works great if what you're multi-tenanting is a little bit of shared business data under the control of the SaaS provider. But what if it's arbitrary amounts of data? What if you're vending out infrastructure instead. And so that's where we came up with what we call the STAMTI model here. It stands for single tenanted accounts. So every customer gets their own fully replicated data with the fully hardened firewall and security barrier between them and every other node. And then the MTI is the multi-tenanted infrastructure. We've built this, and the resources that we deploy into those separate accounts that we've vended out are going to be made out of serverless components, each one of which has this great scalability, fault tolerance, but also importantly, the cost enveloping of multi-tenanting, so that you can make as little as a single transaction, and that costs what a transaction costs. It doesn't cost an entire server stood up and operating 24/7 by 365 in every node. So we get the best of both worlds here. We get something that has the cost and the scalability of a centralized database, and yet at the same time, it's got the replication, the decentralization, and the operational independence and isolation of having fully separate servers sitting in fully separate cloud service provider accounts. That's what we call the STAMTI model. And then the nice thing about it too is that because Vendia can help deploy those resources in based on the data schema, the data model that you showed earlier, we can make all of this SaaS-style operation so that it's hands-free. Customers can turn that data model into these high-performance, interconnected nodes that can span different things like accounts and clouds with all of that operational and security isolation, and they don't have to write any code, deploy any servers, or manage any infrastructure to accomplish any of that.
Fantastic, Tim. Thanks so much. Yeah, I think, saying that you don't have to write any code is one of the most attractive things about this model to me. Even though I like development, it comes with those burdens, not only in terms of managing things that are shown on the screen like security and operations, but then just maintaining the code and having to iterate on that independent of what I'm focusing on, my applications. So awesome points. So what resources are we actually talking about when we're talking about deploying into these STAMTI model accounts? Well, it's actually easy to inspect this yourself, as we saw just a few moments ago on the Vendia Share Uni dashboard. But let's quickly discuss some of these resources here that I've got on screen, for example. So this is from an earlier test node. But just looking from top to bottom here on the resources, initially we're represented with some information here about that GraphQL API. So again, when we stand up a node, we stand up resources for that node. This is a really key thing to understand about how unis work node to node, because my access patterns might be different than, say, Brian's or Tim's or our customers or our partners. So having our own API or an API key allows us a lot of variability and durability in terms of how we access things. And then I'll tack on top of that, and we kind of talk about this a little bit further in a moment, but this is also the opportunity where we have to configure things like authorization and authentication at the node level. So as my access patterns differ, so might the access model in terms of authorization and permissions, so on and so forth. So we have the GraphQL API, the URL, and the key. I don't show the key here for the sake of the example, but that's what we need just to get in there and query data and to work with it. We also have a nice feature. We'll talk about integrations here momentarily, but we exposed there that WebSocket URL. This can be used to actually subscribe to data in real time using a nice feature called subscriptions. And that's, again, from the GraphQL stack. So that's all generated for you behind the scenes for each node and made available to you to consume. I'm going to kind of skip over the SQS and the SNS topics there. We're going to cover that momentarily. The other item here on screen is the S3 bucket arm. This is really cool. We can also, we saw some examples of working with scalar data like the shopping cart list items, but we can also work with file data. So I can, for example, decide I want to share a file with Brian or Tim or whoever's on my my uni. And I can simply add it to my node, and then it can get pushed out to all the other nodes. Or I can control that access. They can choose whether or not they want a copy of it or not. There's a lot of fine-grained controls that go into that. But just want to point out there that when we talk about the depth of the feature set, Vendia Share is really built around sharing both files and data in that term. All right, so let's look a little bit more globally at things. We said before that those unis are comprised of nodes, and each of these nodes is in an isolated account within a cloud provider. So that's that whole STAMTI model. Each node may represent a different component of our architecture, or like I said, another team or even a partner. The Vendia Share service connects these parties and then ensures that data written to any party is correctly distributed to all of those parties in real time and in that consistent and ordered manner. So let's observe this further from the point of view of a consumer of that data. So each node in a uni provides that boundary at which you can configure authentication and authorization, as I said a moment ago. This allows you, again, a number of different architectural options, such as presenting one node to a specific technology and other nodes to a different one. And it also plays a crucial role in sharing with partners who likely have their own identity and access systems. For example, we might have our mobile users shown here, interfacing via Cognito, or partners using something like Active Directory. So we can certainly give you the flexibility in terms of what you're building to support sharing and your applications built on top of the uni in terms of giving you some flexibility. So what really gets my architectural gears really spinning is when you think about how this introduces flexibility with multiple cloud providers. We're only using AWS right now in the developer preview, but imagine what possibilities exist when we build applications with a uni, when we can present to, say, end users on AWS using really fun services like Amplify. Or if we could conduct data enrichment or perhaps AI ML with Google Cloud. And then we could ultimately share that same data after it's refined with partners or customers in Azure. A reliable data plane that makes sharing trivial really starts to open up some new doors for engineering and for software architecture as a whole. All right, so we've covered some of the basics thus far. We created a uni from our JSON schema of our data model, and we've interacted a little bit with the data in real time. We've also looked at how resources created for us can be used to start creating some new opportunity in terms of what we can build in our architecture. So let's dive a little bit deeper and look at some more of the advanced features of Vendia. So the first advanced feature I'd like to discuss is the ability to integrate Vendia unis with cloud-native queue and function services. Often customers use the API for the great wealth of activities, but there are times when stepping in front of or behind or even in the middle of a transaction with some data can be very useful. We'll talk about that middle part here in just a minute, but let's talk about some of the options we have in terms of reading and writing data. Integrating in that term with Vendia Share is really easy. When each node is created, as we mentioned, it's created with all the resources per node. And among those resources are cloud functions and cloud queues. Queues allow customers or upstream systems even a mechanism with which they can introduce data. While the API is preferred, this gives us some flexibility to integrate with systems already leveraging popular queue services from cloud providers. Cloud functions offer us the ability to enrich or manipulate data as it's being written. This can also help us integrate with other systems as we can easily use cloud function services like AWS Lambda to generate new GraphQL mutations. And again, the mutations are the things that apply or update data. So let's look at this architecturally. Working from our previous example, consider a uni with two nodes. One is presented to clients connecting through AWS, and the other is providing some backend services from Azure. The front end supports some incoming data from customer smart homes. Let's say this data is sent via MQTT. This is very popular, a popular mechanism for transporting IoT data. Now, unis can't speak MQTT natively. It's an IoT thing. So this is the perfect opportunity to transform and enrich that data with a cloud function, and then to insert it into the uni. In this case, we would take advantage of something like a cloud-native IoT service to consume the MQTT messages, and then we'd leverage that service to trigger a cloud function and store the message data with other metadata and whatever we need to enrich that via the GraphQL API on the front-end node. In a very similar fashion on the outbound side, if the backend node leverage services that operate with a different API specification, let's say classic REST, a cloud function can be used to transform in the outbound direction as well. So with outbound integrations like this, the function is invoked for each new underlying data block. So that's really important. It's really akin to that event-driven process we see when we talk about cloud functions and serverless architecture. So we've talked about functions pretty exclusively, but similar patterns also apply to queues and notifications. So we can use things like queues in a similar fashion to consume data, as well as to be notified in a similar event-based pattern when things change. Same thing with notifications. So I definitely encourage you to check out our integrations portion of our public documentation for more details on those things. So we've seen how integrations can start to help us get data into a uni and then out, regardless of the technology or location. We've also seen how the GraphQL API generated from our data model can quickly help us reuse code when it comes to reading and writing. So what's missing? Well, that in-between case that I alluded to earlier. So sometimes we do want to enrich data based on a set of rules, but we can't afford to do so with cloud functions. This could be due to limited resources. Let's say we don't have any developers. Or perhaps we're in an environment where we don't yet have corporate approval for things like cloud functions. A surprisingly large amount of organizations still find themselves there. And there could be other such factors that would prohibit us from taking the cloud function approach. So what if we had the ability instead to simply enrich the data as it was being distributed inside the uni? Well, smart contracts give us this ability. So consider an e-commerce application. When a user wishes to check out, maybe sales tax needs to be computed for the contents of their shopping cart. And this would be necessary before we could prepare something for payment and accept their payment. So customers would provide their geography, when they're logged in or when they're completing the checkout forms. And this geography, let's say, for example, here, Texas in the United States of America, that geography influences their tax rate. So a smart contract can then run inside a uni to automatically enrich the shopping cart data with new information about taxation. This removes the need for us to have an additional operational burden for a cloud function to do that for us. It just works. When the information is consumed downstream or on another node, perhaps one working with a payment processing partner, for example, a complete picture of that information is available. So you can see that we have all the shopping cart data plus the new information added via the smart contract. And our payment processing company is none the wiser that this happened inside of a smart contract. It just simply works. So what's also interesting is we can even consume tax information from our payment partners, since they too are on our network with our uni. In such an example, we've removed an additional burden of the processing logic and master data management for taxation. And we've offloaded that to our partner because they have the data. This really frees us up because now we don't have the operational burden of the logic itself that happens inside the universal application. And we don't have the burden of trying to synchronize data between the payment processing partner. They don't have to FTP us the latest tax data. We don't have to go look that up. They're maintaining that because that's a system of record that is important to them. And then all parties on the network can see it. So that's a really nice way to offload some things there. Now that we've seen Vendia Share work and have covered some of the more advanced features, let's look at how customers are using Vendia by looking at a couple of our most popular use cases. The first one I'll talk through just in brief here is track and trace. And when we say track and trace, we really mean tracking down items in things like supply chains or perhaps orders that are being delivered to customers, and then being able to trace down attributes. Say we have quality issues. Things go missing, they're not delivered. Maybe they're damaged during manufacturing. The track and trace use case really speaks to how we can use things like Vendia Share to help us manage some of those processes and become more economic in terms of how we're going to resolve those. Another popular one, settlements and clearing. The really popular example we have is customers that work with airline ticket transaction settlement systems. Typically, we see a reduction in the time to settle from 2 weeks to 30 minutes. That's an alarming reduction. We'll kind of pick that apart just a little bit, but what we mean by settlement there really is that it's more and more common for something like an airline company to work with different partners. So they might be working with ticketing agencies, different clearing houses, maybe a corporate solution that you'll have within your organization for purchasing tickets. And then they'll negotiate rates, handle the buying, trading, upgrade of tickets, etc. So settlement really speaks to how do they actually go through the different churn and all the different rules that may be applied in those systems and end up ultimately with a payment and a transaction that results in a ticket. So you can imagine there's a lot of complexity in this use case, but again, having a platform upon which all these partners can speak the common language, work with a common data model, really, really valuable in terms of reducing the complexity. And as a result, the time needed for these operations to actually clear. So again, from 2 weeks to 30 minutes is an amazing savings. And the list goes on. We don't have too much time left in this webinar today to go into them, but some of the other use cases we see people really talk about in terms of how they like to use Vendia Share is within the IoT space. And again, with additional master data management, distributed processing cases, and just anything else you might imagine. When people ask me, why or when should I use Vendia Share? It's really, well, anytime you need to share with somebody, regardless of where they are, what they might be doing, or what technology they're using. And lastly, let's talk about a couple of additional benefits before we close out with some next steps in Q&A. Let's briefly kick it back over to Tim. Do you care to walk us through some of the additional benefits?
Of course, thanks, Cory. I'll go through these pretty quickly here. I think we've talked about a lot of them. Just to kind of summarize, what you can do here with a uni, with Vendia Share, is get something that has the simplicity of creating a table on a conventional centralized database, and apply that same kind of workflow and that same kind of data model simplicity to now creating an interdepartmental, multi-party, cross-cloud application. One of the things that's really nice about it is that you can add participants to it as your business needs change. So think somebody else joins your supply chain, but you can also use nodes to model lots of things. For example, it's often really hard in an application. Let's say you want to add a disaster recovery or a new region to lower latency or increase the availability of your application. Well, with a uni, you can do that by just adding a few lines of configuration, and then all of that is done automatically. I think all of us have struggled through the difficulty of adding regions and geographies to existing applications and know just how hard that can be. So converting that into something that can be driven through config is a huge step up. Another incredible advantage here is, while you don't have to care how Vendia Share is implemented and you can build your own application any way you like, everybody gets to take advantage of the fact that we built this serverlessly. So with no infrastructure to deploy, no need to go figure out a Kubernetes cluster, no need to provision that to peak capacity, you can take advantage of the fact that the architecture is designed on a serverless core, which provides perfect utilization and also no infrastructure to deploy or manage. Makes it really easy for companies of all sizes, from two-person startups to Fortune 100, to see this as a solution. Things like storage scale automatically, and hard complex topics like figuring out how to cost effectively transfer data, or things that we take the burden on. And I'll just close by saying, we call this kind of the enterprise trifecta: the convenience of SaaS, the security and isolation of single-tenanted accounts, and the pricing and performance advantages of multi-tenanted infrastructure. So back to you, Cory.
Excellent. Thanks, Tim. Yeah, I definitely like that enterprise trifecta sentiment there. I think it sums it all up. All right, before we close, let's quickly talk about next steps. Of course, we'd like you to reach out. So we've got a couple of different ways that you can start really unpacking Vendia Share and getting your hands dirty with some of the concepts we introduced today. First and foremost, register at share.vendia.net. go get your developer preview account and dive in. And after that, it's really a choose your own adventure. If you prefer to kind of go through the self-guided process, so we've got a number of resources for you in terms of our public documentation, YouTube, and we'll post this webinar video there as well later, as well as the quick starts that I mentioned prior. If you want to get off the ground in a more accelerated fashion, Brian and I are here to help you from the Vendia Solutions Architecture team. We have a 1-week POC process that we would love to get you involved with. And I'll quickly throw that up on screen as well, but you can visit us at vendia.net/POC. And it's really easy to get involved. All right. With that, we can go ahead and close. If you do think of something later, please feel free to reach out. Again, we are going to present this via YouTube, and we will send out a survey via email. Please feel free to respond there if you think of anything we missed, or just indicate whether you enjoyed the presentation or not. We greatly value that feedback, and in turn, we'll be happy to share the recording and the printed copy of the slides from today. So with that, thank you very much for your attendance, and we hope to hear from you soon.